I'm Tobias Schneider from Munich. Toby Taylor on Twitter. I haven't prepared a lot of slides, so actually that's my only slide for today. So I have to watch it for the next 20 minutes. No, okay. Yeah, I haven't prepared a lot of slides, as I said. I just want to demo you a project I've been working on for a while. Actually, I'm working on it since about 4 or 5 years. So, and it all started with the idea to create an VNC viewer in JavaScript. All of you guys know what VNC is? Probably, okay. So I started the first version of that VNC view in JavaScript 5 years ago, and it worked well, but it wasn't really sexy enough to release it. So I was waiting for some sugar to push it out, and that sugar came in form of Node.js. So if you have expected to see a remote desktop solution with JavaScript, that's not what I'm showing you, but I'm showing you a tool that lets you create your own services based on VNC with Node.js. So I think the most of you has used VNC in the past as a remote desktop solution. But under the roof, what it basically does, VNC, it's just a frame buffer that is shared with the clients that are connected to it. So yeah, let's switch to the TextMate and we'll show you some demo. So what I first created is implementation of the remote frame buffer protocol, which is the protocol that is used by VNC to stream all the changes on a screen or on a frame buffer to all its clients. So I can show you a little demo of that. So just start a little VNC server. VNC server. And we're first using a native VNC client to connect to it, just to see how it looks like with a regular VNC client. So let's connect to localhost. Can you see it? Okay, nice. So it's just a little drawing demo. You connect with a VNC client and you can draw on a screen. And you can also connect to it with a JavaScript viewer. Well, let's see if it works. Yep. So what you see here at the left is oh, where's my mouse pointer? Here it is. Is the browser. Is the VNC implementation in JavaScript, which is using WebSocket to connect to the VNC server. For the project, I'm using a modified version of libVNC's library. That is a native C library, which is used by other VNC server. And as you can see, when let's reconnect. So you can see you can draw on the right. That's the native VNC server, and that's the JavaScript VNC server, and you see all the changes in real time. But that's not all. So as I said before, you can with my tool you can create your own services with Node based on the VNC or the remote frame buffer protocol. So, and I give you a little demo how easy it is. So, after you checked out the project in GitHub, you can start a new project. And first, you have to require the node screen module. So let's do this. Screen. Okay. And then you can create a VNC server, a frame buffer, just by let's save it in a variable. So screen dot create server. I'm passing an object, an option, and keyword object as the first parameter, and let's set the dimensions of the frame buffer. So width 800 and height of 600. And the second argument is a callback, which gets fired every time a new client is connecting to the VNC server. And that callback is taking a client object as its argument. So this. So let's print out a little console message every time a new client is connecting to the server. So, and then you can start a server on localhost on port. So let's start a server. Node samples. Oh, there's an error. Let's have a look in here. What happened? Okay, yeah. I have to port first, host name second. So, okay. So now our VNC server is running, and we can connect to it first with the native VNC client. So it's an empty screen, so it's just a black screen having the dimensions we passed to the create server method. And we can also connect to it with the JavaScript viewer. So so once a new client is connected and it fires the callback you pass to the create server function as the second argument, you can listen on that client object. You can add event listener and callbacks and can listen to all mouse events and pointer events. So for example, you can say client on pointer move. Yep. Let's restart the server. Reconnecting to it. I should use syslog, I know, but okay, it's connecting to it. Let's move it a little bit with the mouse. Oh yeah, of course. Damn it. Sorry. Yeah. So we connect, and you can see all the pounder events are fired. We can also lock the current mouse position by this X. Yep. So now we've created our first VNC server, and what a node screen provides you is access to a frame buffer in form of a node buffer, which is just a allocated bunch of memory, which presents a frame buffer just presents a pixel array. When you have worked with Canvas on client side or Canvas in the browser, you know the pixel array when you have a 2D context and you're calling the method getImageData and accessing the data property. So then you get back a kind of array which represents the pixels on the canvas. And that's what you get in node screen. And once you've created a server, you can listen to refresh event. That event is fired 25 times per second. You can define that frame rate by passing it here in that option object. You can see refresh rate 10. So that means that the refresh event gets fired 10 times per second. And the frame buffer, the pixel array, is passed to that callback as the first argument. So that's the frame buffer. So now at that point you can put any pixel sources you want into that frame buffer, and it gets synced with all the clients that are connected to the server. So, I mean, let's make a little game which just puts a white rectangle on the screen for each client that is connected to the VNC server, and all the connected clients can just move their own rectangle over the screen. So frame buffer is just a regular buffer. You can put in there whatever you want. That's so we could use, for example, node canvas to draw into the buffer. So let's require node canvas. Of course, you have to install it first via npm. I did that before. So let's have an array of players that are connected to the game, just an array. So and every time a new client is connects to the server, we create a new player object. I'm storing the current position. Start at 0, 0. Adding it to the list of players. So, and let us control our rectangle with the arrow keys. So let's add some events on it. On key down. So when we check in a switch block which key we have pressed, this key sim case screen key. Node screen also provides some key constants, so you don't have to know which key fires which key code. So you can just use the key object, which is exported by NodeScreen by the NodeScreen module. So you can say on down, just to increase the X by 50 pixels. So let's copy that. Okay. On up, let's decrease it. Okay. And we add one for damn it, I hate TextMate. For right. Okay. To increase Y, not X. Plus that up. When we put left. Is it okay? Okay. And here in the refresh loop, we draw all the players on the canvas. So, but first we have to get the. No, that's wrong here. Canvas. So we can create a canvas. 800, 600. And we need a context. .2D. Okay. Let's clear the screen first. Maybe that's not the most efficient code, but it's okay for a demo. Yep, sorry, clear rect. 600. Nope. Okay. Let's iterate through the players array and draw a white rectangle for each player. Let's do fill style. Let's make them all white. CDX fill rect player position. Let's make 100 in width and 100 in height. Is that okay? Okay, and then we have to copy the pixel data out of the canvas into our frame buffer. So let's do that by creating a new buffer out of the pixel data. Get image data. Position null. So we just want to have the whole canvas and copy it into the frame buffer. Looks good. Let's give it a try. Okay. Let's connect with the native client. Okay. There's our white rectangle. It's not working. Why is it not working? Okay. It's not this, it's player, of course. Yep. So let's see if it works now. Yeah, you can control it. So let's connect with the web client. That should. Damn it. Oh, there it is. Oh. Where's the scrolling? Yeah. Here you can create your own games. You can create your own remote desktop solution based on top of it. You just have to write some simple node bindings that grabs your Mac screen or your X11 screen and just copy that into the frame buffer. And it syncs to all the clients using the VNC protocol. And or creating a super fancy canvas Super Mario game or whatever, and let it run on node side. Or on browsers that support Canvas, you can run it on the client side in the web browser, and for clients that doesn't support Canvas, you can run it on node side. And connecting with, even with older devices like a Nokia Symbian S60 device, they all have VNC clients in Java, and you can play together with iPhone users, with Chrome or WebKit users or Firefox users, whatever. Yeah, I will release it the next days on GitHub, so just download it, modify it, make cool stuff with it, maybe a cool remote desktop solution. Yeah, that's it. Nothing more.